This is the Getting Started video for homework number 5. First thing you want to do is download the homework from Blackboard and read through it. It's a monster. There's 11 steps. It's designed to keep you challenged. Remember, this is boot camp. We're here to toughen you up. Make sure there's some restrictions. First off, you're going to make sure that all your important procedures have a procedure comment block. You're going to make sure that there are 3 blank lines after the end of a procedure and before the next comment block. And you're going to make sure there is no gap between a procedure comment block and the procedure it describes. You're going to make sure your procedures are in the same physical order that they are called in, and you're going to make sure your procedures are not longer than 1 page. Okay, so we have, looks like, wow, 10 procedures with 2 extra credit options. Don't start in the extra credit until you've got everything else done. So you're going to want to make a project called Homework 5, and I'm going to bounce over to Visual Studio, and you can see I've already got the template laid down, copied and pasted in, and I'm going to go ahead and run that to make sure it works. And it does work correctly. That's always a good thing. My solution is Homework 5, and my file, my source code file, is homework5.c. Remember, you can't have a .cpp extension. It must be .c. If you make a mistake, go ahead and right-click and rename that. Back to the homework. Write a subroutine named Display Instructions that will display the following message. Okay, so there's a nice little message. You can take time to read that. I'm going to copy that. I'm going to come back to my code, and I'm going to say, here's my procedure, display instructions. So that is the call, and I now have to go write the declaration or definition. So it's a subroutine. That means the data type, return data type, is void. It is called display instructions. It takes no parameters. I have my open curly bracket, my closed curly bracket, and in the middle there I paste that message. And then I do printf, and I slap a carriage return on the end, and I copy and paste all that in. Bam, 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 bam. And put a little spacing action so it looks pretty. Now there's 1, 2, 3 blank lines between that one and main. Now every important procedure gets a comment block, so we ask ourselves, is display instructions important? Well, it's a procedure in our code, isn't it? Yes. So that means it's important and it gets a comment block. So let's give display instructions and a nice little abstract. Tell the user what's going on. I kind of like that. So I got my definition. I've got my call. What am I missing? My declaration. That's right. So I copied the first line of my procedure, come up here to prototypes, and paste it in. Throw a semicolon on the end, get me some blank lines in there so it's easy to read, and if I did everything correctly, it should run. Ah! It worked correctly. Awesome. Now, that may be sufficient for the code, but it is not sufficient for the grader. I need to put problem number 1, display instructions, so that my grader can easily tell what's going on. So we're done with problem 1. Problem number 2. Write a subroutine named display message that takes an integer parameter named int print count. The subroutine should print the message I love Star Trek /end int print count number of times. Call the display message subroutine from main. So here we made the most basic of procedures a subroutine with no parameters. Now here we are kicking it up a notch and we are passing in a single parameter. So display message I love Star Trek. Okay, got that. So come down here and void, it's a subroutine. We need 3 blank lines, and it is called display message, and it takes an integer parameter int print count, and it's going to display the message I love Star Trek, and it's going to do that print count number of times. Well, that means we need some sort of loop. Well, we ask ourselves, do we know the start, stop, and step? Well, we know we're starting at 1, and we're going in increments of 1, and we're stopping at print count. So that tells us we want a for loop. And our favorite loop control variable is int index. So for int index equals 1, int index less than or equal to int print count, int index plus equal to 1. Throw in our curly braces, indent the code. Here, let me zoom in just a little bit so there it's a little easier to see. And hey, that's pretty good. What am I missing? I'm missing my important comment block. In fact, I should have done that first. That way it forces me to plan what I'm going to do. Print the message X number of times. So we're quite happy with that. That's our definition, procedure definition. We come up and we throw in our procedure declaration, and then we have to make our call from main. So display message, and I want to call that, I'm going to hard code a value. I'm going to hard code that to 10. Compile and run. Oh wow. Now that's all glommed and mashed together, and it's hard to tell the output, or to separate the output for each individual problem. So we have to go back and clean up those procedures. So the first thing we're going to do is we're going to say printf problem number 1 display instructions. Alright, so this is so that both the programmer and the grader can tell what's going on. And we want something similar for problem number 2. So display message X times. Now, to separate the output, we want a printf, and we're going to put in a blank line between each of those. Aha! Now we go ahead and run it. And wait, because man, it's slow. And oh, that is much better. Much easier for the grader to tell what's going on. And that is how we do problems 1 and 2. Problem number 3. Write a function named getLargerValue that takes two integer parameters, int value 1 and int value 2. The function should return the larger of the two values. Call getLargerValue function from main and print the result. Okay, getLargerValue. I think we can do that. So I'm going to come down here and I'm going to copy a procedure that I've already created, and we'll start with the comment block this time. That's a good habit to get into. GetLargerValue. Pass in 2 beers and tell us which one's the best. Return the larger of the 2 values. Alright, now if I'm passing in int value 1 and int value 2 and it's returned the larger of that, that means it's a function. And what should the return type be? Well, it should be an integer. Alright, so I need a variable, and I'll call it L for larger, right? That's a great variable name. No, why is that a horrible name? It's not descriptive, it's an abbreviation, it's missing the prefix. So we'll call it int result. Well, that's not a bad number, or a variable name, but there could be one better. You know what that is? Int larger value. Call it exactly what it is. Do a little if statement action. If int value 1 is greater than int value 2, then int lager value equals int beer 1. Int value 1. Else int larger value equals int value 2, return int larger value. There we go. Now, when to use curly brackets on if statements and for loops? Always. But what if it's just one line? Always. But what if always? The answer is Always. Why? Because we want to be consistent. Now remember proper indentation. All your code inside procedure is indented 1 tab. This is not indented. That's indented 1 tab, and that is indented 2 tabs. So we just want 1. How do you back it up? You hold Shift Tab. All the code inside an if block should be indented. That's not indented. That's 1 tab. That's 2 tabs. We want just 1. There we go. Remember, 1 return statement per procedure. It should be at the end. Whoops, we've got a small bug in there. I've got int value 1 greater than int value 1. That should be if int value 1 is greater than int value 2. So fix that. And also forgot to fix the indentation after the demonstration for the else body. So that is now correctly indented, and we got rid of our bug, and that takes care of the procedure definition. We'll pop up to our prototype section, and we'll paste that in, throw a semicolon on the end. That takes care of our dinner reservations. We've told the compiler to expect guests for dinner. And then we have something for problem 3. We'll go ahead and copy that. We will say, call this get larger value. Problem 3, get larger value. And we will call get larger value. I'm going to just hard code the values. I'm going to pass in 5 and 10. Now because it's a function, we need to return that and set it equal to something. So we'll call a variable get larger value. Now it's going to get mad at that, red squigglies, because it's not defined. So I come up here to the top, paste that in. Bam! Little sound effect action. And there we go. Now, problem is I haven't printed out the result. So printf, the larger value is %d for integer /n and int larger value. Shoo-be-doo-wah. And if I didn't make any mistakes, it should print out 10. Oh, thing of beauty. Quality code that's easy to read and well written. Oh, we love that. And I believe that's enough to get you started on the homework. There's a few landmines in there. Remember what landmines are? Those are things that on the surface you don't see or look simple, but when you get into the details of it, turn out to be really challenging. I got 2 or 3 landmines in here in this homework. And I didn't do that to be mean or cruel. They are just things that you'll run into in business. And it's much preferred that you run into them now at school, when the worst that can happen is you get a bad grade on your homework, you lose points, and you get to resubmit. However, hopefully that will sting just enough so that you'll remember it, so that you'll never ever have to do it again. And that's the whole point of school and learning and growing. And you got to be challenged. Otherwise, there's not a whole lot of point to it. So that is the end of the Getting Started video for homework number 5.